This video will review the answers for questions 4, 5, 6, 14, and 15 from Force Worksheet number 2. So we've got a 7 kilogram mass being pushed by a 3.5 Newton force, so we're going to set that up. So that 3.5 N equals 7 kg times the acceleration. We're going to divide by 7 and divide by 7. We're going to get an acceleration of 0.5 meters per second squared. Given a force of 100 newtons, an acceleration of 5, find the mass. So we're going to say 100 equals 5 m. Divide both sides by 5. Divide both sides by 5. And our m is going to equal 20 kilograms. Sorry, this is getting so scrunched here. Let's see if we can zoom in a bit and get some more room. What is the acceleration of a 24 kilogram mass and an 8 Newton force? 8 equals 24a. Divide both sides by 24. Divide both sides by 24. That will cancel out. Your a is going to equal 8 over 24, which is 1/3 or 0.33 meters per second squared. On the surface of the Earth, a box weighs, ding, 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 49 newtons. What is its mass? Now, initially you might think, wait a second, its weight is its mass. Wrong. Its weight is different from its mass because its weight is the force due to gravity. So if its force of gravity, right, we're looking at newtons here, that's a force, is 49 newtons, equals an unknown acceleration times an unknown mass. Mass is what we're solving for. So the acceleration, since we're talking about the force due to gravity, F of g, we're talking about that 10 meters per second of acceleration due to gravity. So divide both sides by 10, and our mass will equal 4.9 kilograms. The acceleration due to gravity on the moon is 1.6. So while on Earth it's 10 meters per second, on the moon it's 1.6. So now we're going to find the weight of this 10 kilogram mass. So the weight, being the force of gravity, is going to be equal to 10 times 1.6 equals 16 newtons. So remember, we want to differentiate between the ideas of force of gravity, which is also known as weight, versus the idea of mass. Your mass never changes. It's the molecules that you have that make up your body or an object. However, the force of gravity or the weight is going to change depending on what planet you're on. On a planet with more gravity, that object will be heavier. On a planet with less gravity, I'm going to be able to move that object more easily, which is why if you walk on the moon, every little step you take looks like a big jump.